Now that we have the chain rule, we're ready to revisit the derivatives of exponential functions. Recall that we used the definition of derivative to try and find a rule for differentiating exponential functions, and we ended up with this limit. And we found that if the base was e, that this limit was 1, but if the base was anything else, we just kind of looked at a table of values. Now with the chain rule, we're ready to go back and finish that and have a rule. So when we want the derivative of an exponential function, a to the x, I'm going to express this as e to the ln a raised to the x. Now you may not have seen to do this, but can you see that these are equivalent because our exponential e and our natural log ln are inverse functions of each other. They would cancel each other out, and essentially we would have a to the x. Now we know that when we have an exponent inside and outside here, basically we multiply them, so I could express this like so, and so what I have is the derivative as e to the something. So a function inside, this is like e to the u, with u being ln a x. So the derivative of e to the something is e to the something multiplied by the derivative of the something. That's the chain rule, e to the u multiplied by the derivative of u. So e to the something's derivative is e to the something, and then the derivative of the something, well, this exponent ln a is just a constant, so this is just a constant times x, so its derivative is just ln a. Now we can express this again as an e to the ln a and then to the x, and so the e and the ln would cancel, and we are left back with the a to the x, and we now have multiplied by ln a. So our derivative of our exponential function is, we knew that it was the exponential function multiplied by some constant, and that constant now we know is the natural log of the base. So let's go back and see when we were deriving this from the definition of derivative. If you remember, we ended up with this limit, and we looked at a table of values if the base was 2 or if the base was 3, and we saw when the base was 2 this appeared to be approaching 0.69, and if the base was 3 it appeared to be approaching this 1.0986. Well, now we know that this limit equals the natural log of the base, and in fact the natural log of 2 is 0.693. You can see that we were accurate here, actually out to like 5 decimal places, and we can see that the natural log of 3, we can see again our accuracy out here 5 decimal places, and so the limit as h approaches 0, this a to the h minus 1 over h is just the natural log of a. So we now can differentiate all of these exponential functions.